All right, guys, welcome to day 3 of week 5 of chemistry. So in day 1, we did a review of oxidation numbers. And if you have not watched that video, you need to go watch it immediately because oxidation numbers are the precursor for redox reactions. So if you don't know how to master oxidation numbers, 1, you won't be able to do your homework, which is found on day 2. It's a review sheet of oxidation numbers. But also you won't be ready to do redox reactions. Also, with the oxidation numbers, we got a little bit deeper, so we started figuring out the oxidation numbers for polyatomic ions and such. So again, you need to watch day 1 video, so don't skip ahead because otherwise you're going to be lost when we start doing redox reactions. So today is day 3. So today we're going to be talking about what redox reactions actually are. So before we can actually do anything with them, we need to be able to understand how to read them. We need to understand what we're looking at and what it means in chemistry. So oxidation reduction reactions are also known as redox reactions. So anytime I say redox, that is short for oxidation reduction reactions. And all this is describing is the electrons moving between atoms. That's why oxidation numbers come into play, because oxidation numbers are the actual numbers of electrons being added or lost, but redox reactions as a whole are the process of electrons moving between atoms. So if you look at this picture right here, we have atom A and atom B. So these are two different atoms. So we have an electron leaving atom A and going to atom B. This is an example, a very simple example of a redox reaction. So we're describing the movement of electrons with redox reactions. So this gets a little bit confusing, but just hang with me because I have a couple of tricks for you to learn in order to remember it. So we have oxidation and we have reduction. Let's talk about oxidation first. So oxidation is a loss of electrons. So in this example, in the little picture, atom A, oxidation is taking place. Atom A is being oxidized because atom A is losing an electron. The other thing that's happening is what's called reduction, which is a gaining of electrons. And I know it's kind of like, why would we call a reduction a gain of electrons? Like, why would we use that word to describe a gain of electrons? And it actually makes sense because electrons are actually negative charges. So really, the more electrons you gain, the more negative that the number gets. Anyways, you don't need to worry about that. Just remember that it's the opposite. And we will, I have a little mnemonic device that you can use in order to recall and not get that confused. So just remember, reduction is actually a gain of electrons. So in this example, atom B, reduction is taking place. Atom B is being reduced, but it's gaining an electron. All right, so an easy way to remember this is either using the mnemonic device oil rig or Leo the Lion says grr. So let's do oil rig. So with oil rig, oxidation is loss of electrons. Rig, reduction is gain. Okay? With Leo the Lion says grr, loss of electrons is oxidation, and grr is gain of electrons is reduction. So those are two ways that you can remember that oxidation is actually a loss of an electron or electrons, and reduction is actually a gain of electrons. So again, in this picture, atom A is being oxidized and it is losing an electron. B is being reduced and it is gaining an electron. All right, guys, let's go ahead and look at a real life example. So for sodium chloride or NaCl, so when it's an ionic compound, we have a transfer of electrons happening. Okay, so remember, we have sodium as our cation, which means it's a positive ion, it has a positive charge, and then we have chlorine, which is our anion, which is a negative ion, so an atom that has a negative charge. So what's happening is sodium is giving chlorine an electron in sodium chloride. So sodium is losing or giving, so it's losing an electron. So that means sodium is the atom that is being oxidized in this example. Chlorine is being reduced, but it is gaining an electron. So a way to think about this is that electrons have negative charges. So the more electrons you add to something...
I don't know that one.
Alexa thought I was talking to her. No, stop, stop. Electrons have negative charges. So the more you add electrons, the lower the number is going to be. So for example, when I add an electron to chlorine, it's going to make it a negative charge, right? If I were to add another electron to chlorine, it would be a -2 charge. So it's going down in the value system of numbers, if that makes sense. If that's not a good way for you to visualize it, then just throw out what I just said. And remember, oil rig and Leo the lion says grr. But if it's good for you to realize, like, okay, if I look at this mathematically and electrons are negative, and I add it, and it's going to reduce my number, then think about it that way. But not everybody's brain works the same way. So this is what's called half reactions. So oxidation and reduction always occur simultaneously. So if something is giving up an electron, something has to be ready to receive an electron. So the way that we write these half reactions, and I'll explain in just a second what that actually means. But so chlorine, when it gains an electron, so this is sodium chloride. When chlorine gains an electron, it now has a negative charge. So reduction is written on the left side of the arrow. So remember, chlorine is being reduced, which means it is gaining an electron. Sodium, on the other hand, is being oxidized, and we write oxidation to the right side of the arrow. When we're dealing with half reactions, this is what it's going to look like. And by half reactions, I mean we're just looking at one of the atoms occurring. We're not looking at sodium chloride together, just breaking it down to individual atoms and what they are doing specifically. That's half reactions. All right, guys, hopefully that makes sense. That's kind of an introduction to redox reactions. So be sure that you're really familiar with oil rig and Leo the lion says grr. Those are really, really helpful ways to remember this. I know that it's so weird. Why would we call oxidation a loss of electrons while we call reduction a gain of electrons? But once you get it into your brain, you'll be good to go. So on day 4, we're going to be talking about something called oxidizing and reducing agents. So be sure that you watch day 4, and be sure that you also work on your oxidation number homework, because at the start of next week, we will jump right into how to actually do these problems involving oxidation numbers and what that looks like on a big scale. It's going to be way easier than you think it is, but you got to be able to master the oxidation number part first. Little last minute visitor for this video. But I also wanted to announce to you guys that you will be having a test on Friday, May 1st on Chapter 17. So I know that that seems like it's forever away, but it's actually next Friday. So just be sure that you are aware of that. So we will be finishing up this chapter early next week, so that way y'all can do a great job on your test Friday. So, all right, guys, I am still in the process of grading your tests from this past week. Hopefully they will be up by Wednesday, April 22nd. If there's any delay, I will let y'all know. But if you have any questions about anything, let me know. And don't forget about your homework.